Here are the answers for the section 9-10 homework. We're asked to solve several equations. Number one, we have an equation where the variable is in the exponent, and it doesn't look like we can easily make like bases. So let's solve the equation by taking the common logarithm of both sides. The log of the 4 to the n, and I'll squeeze in the word log right in front of the 60. When taking the log of a power, the exponent on the power can be brought in front of the logarithm. So log of 4 to the n can be written as n times log of 4. And on this side we have log of 60. To get the letter n alone, we need to use division. So the log of 60 divided by the log of 4. This is something to type in the calculator. The answer is 2.95. For number 3, we have an equation that has the variable in the exponent, and again, we cannot easily make like bases. So let's solve by doing the logarithm of both sides. On the left side, we get x times log of 11, and on the right side, the log of 4.75. Then use division to get x alone. Type that in the calculator. The answer is 0.649. Number 5, we have an equation. This time the variable is the base, not the exponent. We can solve this by raising both sides to an exponent that is the reciprocal of this exponent. That would be to the 4th power. That gets the letter x alone. And on the right side, type in 7.06 to the 4th power. The answer is 2,484.38. Number 7. Again, the variable is not in the exponent. First, let's divide by 3. That gets the y to the 2/5 power alone. And on the right side, 17.28 divided by 3 makes 5.76. Next, let's remove the exponent by raising both sides to a power that is the reciprocal of the exponent. That would be the 5/2 power. This gets the y alone. On the right side, type 5.76 to the 5/2 power. The answer is 79.6. Number 9, this time the variable x is in the exponent. We could solve with logarithms, but our other option is to rewrite this and try to use the same base in both places. And I think I can do that. The number 27 is equivalent to 3 to the 3rd power. So we can replace 27 with 3 to the 3rd. On the right side, the number 1/9 is 3 to the -2 power. Now use the rule about multiplying the exponents together. Keep the base and times these exponents. This is 12 minus 3x. On the right side, keep the base 3 and times the exponents. -2x plus 2. Because the bases are equal, the exponents must be equal. Then solve this equation. We could add 2x to the left side and subtract the 12. That makes -x equals -10. Therefore, x is equal to 10. Number 11, the variable x is equal to this logarithm. So x is the value of this logarithm. We can find the value of this logarithm by using the change of base formula. The log of the argument divided by the log of the base. Type that in the calculator. The answer is 0.63. Number 13. Again, the variable is equal to the value of that logarithm. So let's use the change of base formula. The log of the argument of the logarithm divided by the log of the base. Type that in the calculator. And the answer is 0.757. Number 15, again we have a logarithm equal to a variable. So that variable is the value of the logarithm. We can use the change of base formula again. The log of the 5 divided by the log of the 2.718. Type that in the calculator. And the result is 1.61. Number 17, our equation has the variable in the exponent. We can solve by doing the log of both sides. So squeeze the word logarithm in front of both of those expressions. On the left side, the exponent, which is x minus 3, can be multiplied in front of the log of 5. And on the right side, we have log 27.1. Now use division to get the x minus 3 alone. In the next step, what will you do to get the x alone? You have to add 3. So the answer will be 3 plus the value of that logarithm. Let's type in that expression in the calculator to see what it makes. That expression is 2.05. So when you add the 3, the answer is 5.05. Number 19, we have an equation where the variable is in the exponent. Let's take the log of both sides. On the left side, we have the 2s minus 1 times the log of 3. And on the right side, the log of 64. Now use division to get the 2s minus 1 alone. Next, you would have to add the 1. And let me type in this expression to see what it makes. It's 3.785. When you add the 1, it's 4.785. Finally, what do you have to do with the 2 to get the s alone? You have to divide by 2. So on the calculator, take the 4.785 and divide it by 2. The answer is 2.39. And last, number 21. Where is the variable in the equation? It is in the exponent. So the technique is to do the logarithm of both sides. This makes t plus 2 times the log of 10. And on the right side, we have the log of the 241.3. To get the t plus 2 alone, we divide by the log of 10. However, do you remember what the base of a common log is? It's base 10, even though the little 10's not shown. So the base 10 log of 10 is simply a 1. So if log of 10 is really just a 1, then you don't have to take the time to divide by it. We just know that t plus 2 is equal to the log of the 241.3. Let's type that in the calculator to see what it makes. It's 2.382. Then subtract the 2 to get the t alone. The answer will be 0.382.